afternoon, Engineer Jamer Punsalan, and also to my classmates. So, I am Don Carlos C. Pulintan, and I am from CIT 04903E. So, the topic that was assigned to me is to report about solar power plant. So, I'm going to start by discussing what is solar energy. So, the word solar originated from the Latin word sol, which means sunlight. So basically, it's the energy that we can absorb from the sun. So now that we have known what is solar energy, so let's now discuss what is solar power. So what is solar power? Solar power is the conversion from sunlight into electricity, either directly using photovoltaics, indirectly using concentrated solar power, or a combination of the two. So photovoltaics involves the use of solar panels either in rooftops or in ground-mounted solar farms, while in concentrated solar power, which is also called concentrated solar thermal energy, involves the use of steam thermal, which is thereafter converted into electricity by the use of a turbine. Mainstream technologies. Many industrialized nations have installed significant solar power capacity into their grids to supplement or provide an alternative to conventional energy sources, while an increasing number of less developed nations have turned to solar to reduce their dependence on expensive imported fuels. So, in our country, this is only used as an alternative as of this moment, because it can serve as an alternative energy source for those areas that are far enough from the other sources of energy. Photovoltaic cells. A photovoltaic cell is a device that converts light into electric current using the photovoltaic effect. The first solar cell was constructed by Charles Fritz in the 1880s. The German industrialist Ernst Werner von Siemens was among those who recognized the importance of this discovery. In 1931, the German engineer Bruno Lange developed a photocell using silver selenide in place of copper oxide. And in the 1940s, researchers Gerald Pearson, Calvin Fuller, and Darrell Chapin created the solar cell in 1954. So these early solar cells cost $286 and it had efficiencies of 4.5 to 6%. Now let's discuss about the components of a solar cell. So as we can see in this picture, sets of modules can be wired together to form an array. Then this array now will be able to absorb the energy from the sun, which is converted into alternating current by the use of an inverter. Then the energy now will flow through the fuse box, which can power up any kind of load, whether it's residential, commercial, or for industrial use. Batteries and other additional power generators can be used as backup sources of energy. Then the excess energy will flow back to the grid for distribution purposes. Such power plants require operation not only in nighttime but in limited times of daylight also. So now let's discuss the other method of solar power generation, which is called concentrated solar power. Concentrated solar power is also called concentrated solar thermal, and it uses lenses or mirrors and tracking systems to concentrate sunlight and then use the resulting heat to generate electricity from conventional steam-driven turbines. So there is a wide range of concentrating technologies that exist in this age of time. Some of them are the parabolic drone, the compact linear Fresnel reflector, the solar dish, the solar power tower, and the solar pond. So in the succeeding slides, I will discuss to you briefly each of its operation. So now let's discuss the first example, which is called parabolic drone. So it uses parabola-shaped reflectors that are able to focus between 30 and 100 times above the normal sunlight levels onto the collector. The method is used to heat a special type of fluid, which is then collected at a central location to generate high pressure superheated steam. So in this picture you can see solar energy generating system, the largest operating solar thermal plant in the world, which is located in Mojave Desert, California, United States of America. So now let's discuss the next example, which involves linear concentrating systems. So it is sometimes called as Fresnel reflectors, and it also consists of large fields of sun tracking mirrors that tend to be aligned in a north-south orientation to maximize sunlight captivity. So this setup allows the banks of mirrors to track the sun from east to west throughout the day. So in the next slide, I have prepared a 6-minute video on how Fresnel reflectors operate, and it also explains how does it produce electricity. Yes, so let's now discuss about solar dishes. So somehow it's quite similar with Fresnel reflectors because it also uses mirrors to focus on the sun's energy into a collector. So this tends to consist of oversized satellite dishes that are clad in a mosaic of small mirrors that focus energy onto a receiver at the focal point. So I have prepared in the next slide a diagram on how the solar dishes operate and how does it also produce electricity. So this picture shows how solar dishes operate. So as we can see there, the solar energy is being absorbed by the concentrator, which activates its power conversion unit from solar thermal energy into electrical power, which is now transported into the grid for distribution purposes, etc. Now, let's discuss about solar power tower. So, it is an interesting method in which hundreds to thousands of flat tracking mirrors reflect and concentrate solar energy onto a central tower. So as we see in the picture, it is currently happening, and in the next slide I have prepared a short video that explains about the operation of solar power tower and how does it produce electricity. So let's jump ahead. we have done explaining the different generation methods that employs the use of solar energy, now we can talk about the advantages and disadvantages of using solar energy as a method of electricity generation. So first, let's talk about advantages of using solar energy. First advantage is it is a renewable energy source. The most important thing that we could assure is that solar energy is a renewable energy source. So we are blessed enough to be living near the equator because it can provide us enough amount of energy that we can use in our daily lives. So it can be harnessed in all areas of the world and is available every day. So we cannot run out of solar energy unlike other sources of energy unless someone brave enough would go make the sun disappear. Second one, it reduces electricity bills. Since you will be meeting some of your energy needs with the electricity your solar system has generated, your electricity bills will significantly drop. So it will depend on how you will consume your electricity power and the amount of energy you will receive. Now let's discuss further the advantages of using solar energy. It has diverse applications, so it can be used for various purposes. We can generate electricity by the use of photovoltaics in those areas without access to the energy grid. We can also produce heat by the use of solar thermal energy. So this proves the point that I have discussed in the earlier slides. Aside from this, we can also use solar energy to distill water to those areas without access to clean water supply. And it can also power up our space satellites. Next, it has low maintenance cost. So solar energy systems generally don't require a lot of maintenance. So we could just keep them relatively clean and safe from any moisture. So cleaning them a couple of times would do the job. Most reliable solar power manufacturers offer 20 to 25 years of warranty. So that's why we don't need to worry that much. Next, let's discuss about technology development. Technology in the solar power industry is constantly advancing and improvements will intensify in the future. Advancements in quantum physics and nanotechnology could potentially increase the effectivity of solar panels. And it could also double or even triple the electrical input of the solar power systems in the near future ahead. Let us discuss now the disadvantages of using solar energy. First, the cost. The initial cost of purchasing a solar panel system is fairly high. This includes the payment for the solar panel, batteries, inverter, wiring, and the installation of the whole system. Next, it is weather dependent. Solar panels are dependent on sunlight to effectively gather solar energy. Although we can still gather solar energy in cloudy and rainy days, the efficiency of the solar panel may drop. So as I have written there, the electricity that we can produce is directly proportional to the sunlight that is being absorbed by the solar panel. So if it is a rainy day, so we can expect less electricity produced. Solar energy storage is expensive. It has to be used right away, or it can be stored in large-scale batteries. So these batteries could be charged during the day, so that we can still collect energy even if it's nighttime. it also uses a lot of space. The more electricity you want to produce, the more solar panels that you will need, as you want to collect as much sunlight as possible. This case mostly affects those people who are living in residential areas. So the size of your roof can affect the number of solar panels that you can install in your unit. And finally, it is associated with pollution. Although pollution related to solar energy is far less limited than those other sources of energy that we know, it can be also associated with pollution. Transportation and installation of solar power systems are said to be associated with the emission of greenhouse gases. And as we all know, greenhouse gases is a great serious environmental matter that we must solve in order for our world to last longer. And that's it. But before that, I would like to present a short video about the future on which solar energy could offer to us in the coming times ahead.
Professor Vladimir Bulovich is an expert in solar energy and nanotechnology at MIT's School of Engineering. He's fanatical about small things, really small things. We're talking quantum scale.
This picture is of a soap bubble, and on top of it we rested one of our solar cells to demonstrate exactly how little it weighs. 2.5 micron device, that's just roughly speaking about 1/40th the thickness of your hair. That is as thin as we need to make a structure that at the end will generate the electricity.
MIT is a private research university, widely considered to be one of the world's most prestigious. Professor Bulovich and his colleagues are designing extremely lightweight organic photovoltaic cells. But why the focus on the small?
Nanostructured solar cells can be made semi-transparent, in which case you might use them as the lenses on your sunglasses. And as a result generate power next to your ears, where you might have a hearing aid that would never need to be recharged again, or maybe a Bluetooth radio, again, that would never need to be recharged again. If you have it on your e-tablet, you'll be able to generate power through a transparent nanostructured cell.
In theory, these tiny solar cells could be used not only on portable devices, but rigid structures. Look at the skyline of any modern city, and there are millions of square meters of glass.
Go bigger as you develop a technology, and you can now start thinking about using it on the surface of every glass window on a skyscraper. The heat that you capture in form of infrared light, you can actually convert into electricity that can power that building.
It's likely to take years, perhaps decades, before transparent solar cells are widely available.
Grids need to be changed, power storage needs to be reinvented. These are things coming up for us. Yet it is obvious that as you look into the next decade, a very significant fraction of world's electricity will be provided by solar.
As a final remark, I should say I truly believe in the power of solar energy because it can offer us many possibilities that we could do in order for our lives to be better. One of which is it can help us produce more jobs as we build more solar power plants in various parts of our country. And in the long run, it can help us build up our economy. And other one is it can help our fellow Filipinos who does not have any access to the power grids to be provided with a new ray of hope that there's something better arriving for them. And this is the end of my presentation. I hope that you learned something relevant about solar power plant. And this was Don Carlos Cipulintan wishing you the best. Happy holidays. And wherever you are, stay safe please. Bye.